Today we will be finding the volume of right prisms. Volume is how much space is being occupied inside three-dimensional shapes like this. To find the volume, we just follow the formula V equals BH. The B stands for the area of the base, depending on what shape the base is. And then the H stands for the height of the prism. Let's go ahead and do a pretty simple example to start us off. Here we have a rectangular prism. To find the volume, we always start with the formula. Volume equals area of the base times the height. In this case, I'm going to choose this part as my base. To find that, I'm going to find the area of it, which is 12 times 6, which gives us 72. Now we have to multiply that with the height, which is in this problem 20 centimeters. Go ahead and multiply them together, and our final answer for volume is 1,440 centimeters cubed. All right, let's go ahead and do the volume of this triangular prism. Again, start off with the formula. Volume equals area of the base times the height. Now, a lot of people might think that this right here is the base just because it's on the bottom. But remember, in prisms, there has to be two identical bases that are parallel to each other. And that has no twin base. So that is not the base that we were looking at. We are actually just going to go ahead and treat this as the base, because if you notice, there's one in the front and then there's one in the back, and then they are parallel to each other and also identical. So that's how you know that those two are the bases. All right, so let's go ahead and find the area of the base. It is a triangle, so the formula for the area of a triangle is 1/2 base times height. Its base is 5 and its height is 8. Go ahead and do that calculation to get 20. That 20 goes ahead and goes into our original equation, and all we have to do now is find the height of the entire prism. In this case, it is 10. Multiply them together, we have 200 units cubed. Another reminder, whenever you're finding volume, you have to remember that the units are always cubed. How many cubes can fit inside the three-dimensional shape? So here we have another triangular prism, but it's a little bit more difficult to solve for. Let's go ahead and start with the formula again. Now let's go ahead and find the area of the base. Again, the base of this prism is a triangular face. To find it, we're going to use 1/2 base times height again. The base of this triangle is pretty easy. It's that 12 that's right there, but the height is a little bit different. You have to do a little bit of work. There is the height. Notice I cut the equilateral triangle right down the middle so I can solve for the height. Now I'll draw it to the side. Notice the hypotenuse is 12, but the bottom now, the base, is only 6 because I've split that 12 in half to get the 6. To find the other leg, you're going to go ahead and use that Pythagorean theorem. Go ahead and apply it. You will get that the missing leg is about 10.3923. That little squiggly symbol is actually not the symbol for approximately, but I couldn't find it on my computer, so I'll just use that for now. Alright, so we found the height of the triangle. We're going to go ahead and put that back into our second equation to find the height, and then multiply all of those together to get the area of the base to be 62.3538. And all of that work was just to find the area of the base, which now we can plug into the original equation for volume. There it is, and then the last step is just to multiply that base with the height to get the volume, the height being 15 to get our final answer, 935.3074 units cubed. All right, let's go ahead and find the volume of this regular right hexagonal prism. Start off with a formula. Volume is equal to the area of the base times the height. In this case, the area of the base is a little tricky to find because it's a hexagon. It was a couple of chapters back when we learned how to find the area of regular polygons. Here is the formula. To find the area of a regular polygon, you just do 1/2 apothem times perimeter. Let's go ahead and remind you guys what the apothem is. It's right here. So we have to find that piece to help us find the area of that base. Let's go ahead and draw it on the side. That's what we're looking for, is the apothem. Let's fill in some information that we know. Since one of the sides is 14 yards, we can figure out that this piece is 7 yards because it's exactly half. And then we also need to find the angle that's right here. Okay, if you guys don't remember how to find that, I'll give you a reminder. It is 360 degrees divided by how many sides there are. In this case, there are 6 sides, so it's 360 degrees divided by 6, and that gives us 60. But then we have to split that in half to get just half of the triangle, and that will give us 30 degrees. So there we have it. It's in 30, 60, 90 right triangle. Hopefully you guys remember the rules to solve for the sides of a special right triangle. If you do remember, then you'll know that the apothem right here is going to be 7 square root of 3. If you don't remember the rules, that's fine. We also learned a different way to solve for the missing sides of any right triangle, and that's using SOHCAHTOA. In this case, we're going to use tangent. Tangent of 30 is equal to the opposite over the adjacent. So there's our setup. Tangent of 30 is equal to 7 over a. Use your calculator and a little bit of algebra to solve for a. And we do have a is equal to 12.1244. That is also the same as 7 square root of 3, if you guys remember the properties of special right triangles. So all of that work was just to find the apothem. Let's go ahead and plug that into our second formula. And then the next part is to find the perimeter of the base. The perimeter is pretty easy to solve for. It's just adding up all the sides. Notice one of the sides is 14, so there's 6 of them. 14 times 6 gives us 84. Go ahead and multiply all of those together to get the area of that base, which is 509.2229 yards squared. Okay, now we can use that answer to plug into our original equation to solve for the volume. The last step is just multiplying our area of the base to the height of this prism, which is 25. Use your calculator to multiply those two together to get our final answer. 12,730.5734 yards cubed. All right, let's go ahead and find the volume of a cylinder. How much space is needed to occupy the inside of the cylinder? As you can see, the formula for the volume of a cylinder is exactly the same as any right prism. It's just volume equals area of the base times the height. The only difference is the area of the base is the area of a circle, which we know is pi r squared. And then of course the h stands for the height of the prism or the cylinder. Let's go ahead and do a pretty easy example of finding the volume of a cylinder. We'll start off by writing the formula again. Volume equals area of the base times the height. There is the base. It is a circle. There's the formula for the area of a circle, pi r squared. The radius, if you notice in the picture, the line is drawn all the way through, and it is labeled 32, which means that that's the diameter. So to find the radius, you just have to divide it by 2 to get 16. And then use your calculator to go ahead and punch in all of that. Remember not to use just 3.14 for pi. Go ahead and use the pi button on your calculator so that it doesn't round what pi is. And we will get about 804.2477. And then just plug that back into our original formula. And then the final step is just to multiply that by the height, which is 50, to get the volume 40,212.3859, again, units cubed. All right, let's go ahead and go backwards with this example. Notice that they give you the area, they give you the volume of the prism, and they're asking for you to go backwards to find the height. We do the same thing. We start off by using the formula. Volume is equal to the area of the base times the height. And then we're going to go ahead and fill in what we know, mainly the volume, 288. And then we figure out any other information we have, mainly the base. The formula to find the area of that base is just length times width. This is 4 times 6, which gives us 24. We can plug that back into the original equation, into the b, and then this is just a pretty simple pre-algebra problem to solve for h. Divide both sides by 24, and we have the height to be 12 centimeters. So we're going to go ahead and save these last 2 slides for next time when we do composite volumes. So you guys are done for now. Thank you.